So let's begin with the mineral map. Globally, iron making rely on hematite, magnetite, limonite, and siderite. In India, Odisha and Jharkhand offer hematite with a goethite blend, especially in Normandy, Joda, and Goa. Chhattisgarh's Baladila is rich in high-grade hematite. Goa, however, has a limonite, low-grade, high moisture ore. Here is the trend as high grade blue hematite deplete, we are shifting towards goethite ore with high LOI, meaning more chemically bound water and more operational challenge. Now, LOI loss of ignition. Loss of ignition is a mass of volatile matter released when ore is heated to up to 1000 degrees centigrade. It includes water from hydroxyl group, CO2 from carbonate and organics. Typical LOI value dense hematite having a 0.2 to 2%, goethite 3 to 10%, and siderite even up to higher. Now, uh, let's see about a mathematics. If LOI is 10%, then only 900 kg of solid burden reaches the lower furnace per ton charge. This is what it means. Now, this dilution demands precise burden adjustment to maintain productivity. At the same time, we have to also see the operational indexes calculated as for this. Now coming to the thermodynamics energy cost, LOI is not just mass loss, it's an energy sink. So volatile release is a basically endothermic, it absorbs heat and quenches the upper shaft. Now formula, if we have interest, every 1% LOI cost around 2.5 to 4.2 kg per ton of hot metal coke penalty, or we can say this much increment we have to do in coke rate to maintain raft blast temperature must raise to 15 to 20 degrees centigrade per 1% LOI. Carbonate ore like FeCO3 and CaCO3 consume a huge amount of heat energy, around 430 kilocal per kg during decomposition, more costly than pre-calcining. So what is the bottom line? The bottom line is LOI drives up fuel cost and thermal instability. Now coming to the aerodynamics part, as we have discussed already, thermodynamic and energy cost. So let us see. There's aerodynamic part. So high LOI ore causes thermal decrepitation, like steam pressure burst ore lump into fines. And in earlier presentation also we have shared on this phenomena. These fines fills void, reducing permeability, and using Arabian equation, a 5% increase in fines consequently result into 20 to 30% rise in pressure drop. This leads to hanging, slipping, and gas channeling. Gas escape to the periphery, overheating walls, damage the steps. So, loss of ignition is not just a chemistry, so it's a full blown aerodynamics risk. Now coming to the our mitigation strategies, which is ultimate way out. Here, how to fight back. Center working philosophy. We need to maintain a coke chimney at the core to preserve gas flow, and maintaining this center working chimney is also very clever task, because we cannot keep the opening aperture very wide, otherwise our utilization will drop. We must have to keep it very narrow, and that balance we have to see from the also by central working index and peripheral working index, and the differences of it over a period of time. So that gives us a right indication. Now, as for the pre-processing is concerned, dry lump ore using west heat and pre-screen fines before charging is must, and This is need of the hour to combat those fines generation issues. Slag engineering is also a tremendous way out to combat the abnormal situation caused due to these LOIs. So high alumina from the goethite ore, we need to add some Mg to improve fluidity. Otherwise, slag will be viscous and evacuation will affect drastically, and this will also mitigate to have a better evacuation of hearth, and this strategy also stabilizes the body movement and protect the forest health also. So LOI is mostly overlooked, but it affect a lot of things that we have seen: body mass, fuel rate, permeability, and so many things, even slag. So as India transition to goethite ore, we must adopt these all philosophy: drying, screening, slag design, and central working are no longer optional, they are essential. So we want to go deeper into softening melting behavior of Indian build, and next time we have to see how these things